How did math finally accept negative numbers? Have you ever wondered how negative numbers became a part of mathematics? It is a fascinating journey that spans centuries and cultures. Let's break it down together. Negative numbers representing values less than 0. This concept was hard for early mathematicians to grasp. Imagine trying to explain -3 apples. It just didn't make sense to them. Greek mathematicians, like Diophantus, dismissed negative solutions as absurd. This view lingered in Europe for many years. The first recorded use of negative numbers comes from ancient China. In the 9 chapters on the mathematical art, dated around the Han period, Chinese mathematicians used colored counting rods to show both positive and negative numbers. They even created rules for adding and subtracting these numbers. In India, mathematicians like Brahmagupta in the 7th century also worked with negative numbers. They recognized 0 as an important number and established formal rules for operations involving negative values. Despite these early advancements, negative numbers faced strong opposition in Europe during the Middle Ages and Renaissance. Many European mathematicians thought of them as meaningless. In the 15th and 16th centuries, Nicholas Chuquet and Michael Stifel labeled them absurd. Even in the 18th century, Francis Mazars criticized negative numbers for complicating algebra. The turning point came in the 17th and 18th centuries. Mathematicians such as John Wallis, Leonhard Euler, and Carl Friedrich Gauss began using negative numbers more freely. Wallis introduced the number line, which visually placed negative numbers to the left of 0. This helped clarify their meaning. Euler and Gauss incorporated negative numbers into their theorems, showing how useful they could be. By the 19th century, British mathematicians like Augustus De Morgan and George Peacock formalized the logical foundations of arithmetic. They demonstrated that negative numbers could be defined within algebraic systems. This resolved earlier doubts and allowed negative numbers to become a standard part of mathematics. Today, understanding negative numbers is straightforward. The number line is a great tool that shows negative values as less than 0. This makes it easier to visualize operations like addition and subtraction. Negative numbers are essential for solving equations and representing real-world situations, such as debts or losses. So, how did math finally accept negative numbers? Early cultures in China and India developed rules for them. European mathematicians initially rejected them as meaningless. The introduction of the number line and formal algebraic systems clarified their meaning. Finally, the formalization of arithmetic laws established negative numbers as a fundamental part of mathematics. This history illustrates how mathematical concepts evolve over time. Negative numbers are now an essential and approachable part of algebra and operations with integers.